Howdy. This video will focus on how to set up systems of linear equations from word problems and then solving those word problems. So the steps to set the initial system of equations is step 1, find the variables we are solving for and then assign them a letter. Step 2, determine the equations using the assigned variables. And step 3, solve the system by graphing, tabling, substitution, or elimination. Pretty straightforward. Our first example is pretty simple, I think. The admission fee at a small fair is $1.50 for children, $4 for adults. On a certain day, 2,200 people enter the fair, and $5,050 is collected. How many children and how many adults have attended? Well, step 1, we need to figure out what the variables are. It pretty much tells you in each question what the variables are. It's so how many children and how many adults. Those are the variables. So children and adults. So let's say C is for children and A is for adults. Now we need to focus on the equations. It says 2,200 people enter the fair, and also $5,050 is collected. So we're focusing on the amount of people that have entered the fair, and we were focusing on how much money we have has been collected. So let's say that 2,200 is the solution to one equation, and 50/50 is the equation to another solution. So let's have 2,200 equals, as well as 50/50. 50/50 equals. Now 2,200 total people enter the fair. So some critical thinking here. People as in children and adults. So C plus A equals 2,200. So A plus C equals 2,200. Now 50/50 was collected and for the money collected for the fair that day. And if it's $1.50 for children and it's $4 for adults, then we're going to have $1.50 C times C plus 4 times A. So it's going to be 1.5 C. Let's have it this way. Let's have 4 times A plus 1.5 C, because $1.50 is grouped with the children and $4 is grouped with the adults. So we have our two equations now. So now it's set up to where we can solve by elimination. So we either want to get rid of the A's or we want to get rid of the C's. Since the C's have a decimal or a fraction, let's go ahead and focus on canceling out the A's. So the bigger A is 4. So if the bigger A is 4, we need this A here to equal -4. So when we add them, they'll cancel. So we need to multiply the top equation by -4. So bring over, we'll have -4R1, and we'll have -8,800 equals -4 times A minus 4 times C. Bring over row 2, and we'll have 50/50 equals 4A plus 1.5C. Now we have our two equations. Let's go ahead and add down. So -8,800 plus 50/50, that would be it's 3,750, I believe, equals -4 plus 4 is 0, and -4 plus 1.5 is 2.5C. Now we need to get C by itself, so let's divide by 2.5 on both sides. 3,750 divided by 2.5 is 1,500. So C will equal 1,500. So now we have solved for one variable, now we need to solve for the other. So let's go ahead and take this C and plug it in right there. So we're going to have 2,200 equals A plus 1500. To get A by itself, we need to subtract 1500 from both sides. And so A will equal 700. So we have 700 adults and 1500 children, and there we go, problem solved. Next, we have Mike worked 7 more hours than Amanda. Together, they worked 24 hours. Write 2 equations that would be used to solve the system. How many hours did they both work? So let's see how many hours did they both work, both meaning Amanda and Mike. So one of our variables will be Mike and the other will be Amanda. So let's say M equals Mike, so Mike's hours, and A equals Amanda for Amanda's hours. Amanda. Okay. So let's see. Mike worked 7 more hours than Amanda. So more. What's that mean? More means plus. So 7 more hours than Amanda. So 7. Let's say Amanda worked 5 hours. Just saying. So 7 more. That would be 7 plus 5, 12 hours. So we would have this be 7 plus A, so 7 plus Amanda's hours equals however many hours Mike worked, so M. 7 plus A equals M. There's one equation. Together they worked 24 hours. So in total, both of them worked 24 hours. So we're going to have that be A plus M equals 24. Because they both worked, so both their hours combined, A plus M equals 24. Now we can do this by substitution or elimination. We will need to manipulate this equation here in order to solve for elimination, but since it's already set up for substitution, let's do that. So since M equals 7 plus A, we're going to go ahead and take the 7 plus A and replace this M with that. So our new equation is A plus 7 plus A equals M. Equals 24. So now, A plus A, that is 2A. 2A plus 7 equals 24. To get 2A by itself, we need to subtract 7 from both sides. So 2A equals 17. Now we need A by itself, so we're going to divide both sides by 2. And A equals 8.5. So Amanda worked 8.5 hours. So we've solved for how many hours Amanda worked. Now we need to solve for how many hours Mike worked. So let's replace this A right there with 8.5. So we're going to have 7 plus A equals M. A equals 8.5, so we're going to have 7 plus 8.5 equals M. And now, so 7 plus 8.5, that is 15.5 hours for Mike. So we've now solved how many hours did they both work. Next. A landscaping company placed 2 orders with a nursery. The first order was for 13 bushes and 4 trees, which totaled $487. The second order was for 6 bushes and 2 trees, and totaled $232. The bills do not list the per item price. What were the costs of 1 bush and 1 tree? So let's see. 2 variables. What are the costs of 1 bush and 1 tree? So one variable will be bush, and one variable will be tree. So let's say B is for bush, and T is for tree. So we've created our 2 variables for the what we're solving for, and pretty much this word problem tells us pretty much what the equations are already. The first order, or the first equation, was for 13 bushes, so 13B and 4 trees. So 13B plus 4 trees totaled or equaled $487. So we're going to have 13B plus 4T, So 13b and 4t totaled or equaled $487. Equals 487. So now the second equation was for 6 bushes and 2 trees, and totaled $232. So our other equation will be 6b plus 2t totaled or equaled $232. So now we have our two equations, and it's set up to where we can for elimination. So let's go ahead and do elimination. Do we want to cancel the b's or the t's? I'm going to say the t's because that's just easier to cancel out. Our bigger number on the t's is 4. So therefore we need this 2 to equal -4, so when we add them they'll cancel out. So 2 times what equals -4? That would be -2. So multiply the whole bottom equation by -2. So move over row 1, so 13b plus 4t equals 487. And then move over row 2. So -2 times 6 is -12b. -2 times 2 is -4t. And -2 times 232 is -464. Now we're going to add down because we have our two equations we can cancel. So 47 minus 464, that gives us 7 minus 4, that's 3. 8 minus 6, that's 2. 4 minus 4 is 0. And the t's cancel. 13 minus 12 is 1. So we're going to have b equals 23. So we have 23 bushes. Not 23 bushes. We have the bushes equal $232. Next, let's go ahead and so we found our bushes. Now we need to find how much the trees cost. So let's plug how much the bushes cost back into one of our equations. So now we're going to have 6 times 23 plus 2 times t equals 232. 6 times 23, that's 6. Okay, so 6 times 3, that's 18. Bring over the 1. 6 times 2, 12 plus 1 is 13. So 138 plus 2t equals 232. Now let's go ahead and solve for t. In order to get 2t by itself, we need to subtract 138 from both sides. And that leaves us with 2t equals 94. Now we're going to want to divide by 2 to get t by itself. So 94 divided by 2, that is 47. So t equals $47. So a tree costs $47 and a bush costs $23. So we've figured out this example. And I'm going to go ahead and skip this video. Not this video, this slide, because this example is a bit difficult and we're running out of time. So since we're running out of time, hope you enjoy the video, and that's all, folks. I'll see y'all in class.